Oh Lord, here we go, ladies and gentlemen. We're going to take a quick look at one other type of time temperature defrost board. This is an older one. I just want to show you something real quick. This is the old Goodman Defrost board. It's very simple. They've since replaced this in the past couple of years, but if you ever go to a unit and see this out there, don't be afraid of it. It's just a time temperature board. How do you know that? If you look right here on the side, which I've turned it, so if you look right here, there's a 30, 60, and 90 minute 30, 60, and 90 minute time settings for your compressor runtime for it to go into defrost. This is the board, this is the type of board where you would actually have to pull this little jumper pin off of the time selection and put it on the test terminals down here in order to speed up the time. You don't have to use a screwdriver and jump this out. You would actually have to remove that and put on the test pins. So just as a general overview, this board has nothing that the Bryant defrost board doesn't. It's got the high voltage relay that's going to be for your fan, and here are my DF1 and DF2 terminals where my voltage would come in for the fan. It comes off the contactor into this switch. That's a normally closed switch, so of course it's going to come out here on DF2 and actually go out to the fan motor. This other relay right here that you see standing up is going to be our low voltage relays. That is going to be the defrost relay switches between R and O and R and W, or R and W2 as they've labeled it here. Other than that, we have a lot of the same general terminal labels. You've got your power coming in, R and C. You've got your defrost sensor that's going to be attached between R and DFT. We've got O coming in and O going out to the actual reversing valve. So it's coming in from the thermostat and air handler, goes in the board, loops around, and comes back out. Our W2, of course, is going to be an output of power going to turn our heat strips on. But this Y, this board does not use Y for anything other than tracking time. So the principles of the time temperature board are still the same. This is the older Goodman. You can see there's the part numbers and stuff up top. I'm not going to spend a whole lot more time on it because what I want you to see is what they replaced it with. This is the new Goodman, okay? You can see here I've still got the high voltage relay for the fan, the low voltage relays. We've got some other relays. Usually when you see those boxes like that, that's some type of relay in there. High voltage or low voltage, that's pretty much your only two options. But let's take a look at it, and we'll figure this thing out, and I'll show you some field checks here in just a second. So right here on the side, one thing that's different automatically on this new Goodman board is right here. This is a normal and delay. This board actually, just like your thermostat, has a 1 to 5 minute time delay that the cool or heat will flash on before it actually before the thermostat actually turns it on. This board has a timer in it where you can delay startup of the contactor, and you can select that in the field, either keep it on normal on the top two pins or actually have a few minute delay by putting it on the DLY. Okay, so that's one option. If you look right here, there is still the same stuff for a time temperature board. It's a dead giveaway. 30, 60, 90 minute. Got that little jumper right there. We've got the test pins, so if you want to speed up the timing on this board, you take your little jumper selection or your jumper right here off, and you would cover the two test terminals until it sped up into defrost or sped out of defrost, either way. So back again to the same things, right? High voltage relay, we've got DF1 and DF2. You just saw that. That's always for that high voltage fan relay. This is how we turn the outdoor fan off in defrost. Okay, DF1, DF2. Power going in, goes through the switch, and comes out. Okay, now let's look down here, because on this particular defrost board, there's a lot more terminals. Okay, I'm gonna try to get it where the glare is not there. You can see that there is like almost double the amount of terminals on this thing. Okay, a lot of them are the same. So if we look right here, we've got several things that look familiar, right? This R, that's power coming in. R over here, and I've got a common right here. Okay, so that's my power for the board. But look right next to it, right? Look at what they did. They did RDFT. So what does that mean? Anytime you see that R, it's pretty safe on these type of boards like this that there's power sitting on that terminal. That's why they label it R. But they give you a little indication that this is for the DFT. So this is power going out to our sensor, and the DFT terminal is when that coil gets cold enough, the power will return back to that DFT. So that little R, let that be a reminder of what's on that terminal. There's power on that terminal, and it's leaving to go to the DFT. Our W terminal here, that will always be to turn on our heat strips in defrost mode. We've got two O's as well, and look how they separate it compared to the old board. We have regular O, and then we've got an O with an RV. Most heating and air guys in this field, whether you're experienced or learning, starting out, you know that O, if you've ever had a heat pump class or any type of training on it, O is for the reversing valve. So why did they put that there on this board? Well, they're trying to tell you, hey, this is power going in, and this is power, this wire more specifically will be connected to the reversing valve solenoid. So that's power leaving the board to go to that reversing valve solenoid. And here you have the common for the reversing valve. So what's the difference in this common and that common and that common? Really nothing. You could ohm these out, use continuity with your meter, and they're all touching. But they're just trying to tell you and be more specific with the placement of the wires. Something else this board does, right? It has this pressure switch, right? If you look at the wiring diagram on these units, this is a Goodman, it's a GSZ, Golf Sierra Zulu. That particular series, there's a low pressure switch. The logic on these boards are getting smarter and faster, much like furnace boards. This PS1, you see the RPS1, there's power on this terminal going out to a pressure switch. In this case, it happens to be the low pressure switch. It comes back on PS2. That is not a reference to a PlayStation game, okay, or a PlayStation console. So this RPS1, that is going to be power, 24 volts, whether the unit's running or not, and it's going to be leaving to go check the low pressure switch. If the low pressure switch is fine, it's going to come back, okay? And last but not least is Y. We have Y going in, and just like on the old Goodman board, we have no other Y coming out. This board uses that Y input to know when there's a call for heat or cool. It actually goes through the high pressure switch before it gets to Y. So we're checking the high pressure switch and the low pressure switch separately, different terminals. And when I get a call for Y on here, we're going to use the last terminal that we're going to talk about, and that's the CNT. The CNT is for contactor. The way this relay is actually made, or this board is actually made, there's a relay on board that is called the compressor contactor relay. This Y terminal does not directly control the contactor. It talks to the logic on the board to let it know that the high pressure switch has been closed and there's a call for heat or cool. And then this set of pressure switch terminals over here for the low pressure switch will verify the low pressure switch is open or closed. And if everything checks out good, we're actually going to get this delay involved, if there is one. It could be a normal or a delayed signal going to the contactor coil. Forgot what I was thinking right there. But what's going to happen is once the high pressure switch, the low pressure switch, and the delay, if there is one, has been satisfied, then we're going to close the compressor contactor relay on this board, and we're actually going to have power come out of the board on CNT. So just an overview of these things. Boards are always confusing to a lot of technicians. I don't like to see people misdiagnose them, but that's a little rundown on it. I'm going to spend just a couple minutes here in a second, and we're going to go look at a live unit with this board on it, and we're going to do 5 simple checks to show you how you would use your voltmeter to check voltage on this board. So I'll see you out there in just a second. All right, boys and girls, we're going to do one here on this Goodman Defrost board. This is the newer style. I'm going to cover 5 voltage checks you should do. Our unit is running right now, but we already know that in order for this defrost board to do defrost, and to even work for that matter, there's some things that you have to have. And the first one is you have to have 24 volts. So we're going to check 24 volts on this board to make sure that we do have it. I've got my meter set up over here, and it's real simple. What you're going to do is find the common, which is over here on the kind of the top right of these terminals, and you're going to find the R that's coming in to the board. All right, Now if you look right here, there's an R terminal RDFT. All right, R and RDFT should be touching together internally, and you can see that I have 25.5 volts. So this board does have power. The R and the RDFT, and I know it's kind of weird looking at all this stuff here, but right here in this corner, these three terminals are power leaving the board to go to the sensor, and then the return for the sensor. So if you're going to check power, you want to take this third one in from the left, check there to common, and you should have power to the board. If not, this unit won't even run, okay? Because there's that compressor contactor relay that's on the board that lets it run. So that's how you check power. Second check is going to be one more for defrost. How do you check whether you are sensing the coil temperature? If that temperature switch is closed, that DFT switch, you're going to take your one lead and put it on common, and you're going to check power on these left two terminals. Power coming out is the right side of it, and power coming back from the DFT is the left. So we're going to do it with voltage. We're going to check power going out, and I've got 25 volts. If the switch is closed, then power will come back on that DFT side, and there is none. So either in the case of a unit running in heat mode, either you're not cold enough to close the switch, or maybe you have a bad sensor. But you check voltage going out of the board to the switch, I've got 26 volts, and then coming back, I have none. So that is an open sensor. You could check it with continuity. I'm not going to cover that today. Just going to do strictly voltage, okay? The next one you can do is low pressure. These two yellow wires over here on this right hand side over by the common, that's your RPS1 and your PS2 terminal. They are both a hot signal, so you have to check common. So we're going to check RPS1, and I've got 25 volts leaving. That's going to the pressure switch to check it, and it should come back on PS2. And I do have that 26 or 25 volts right there. So power's coming out on the right side on that yellow wire, going to the low pressure switch and coming back on the left. If the unit wasn't running, you could do a simple voltage check, and I mean in less than a minute you'll know if it's your low pressure switch. Okay. The next one is the high pressure switch. If you remember, down here by this R and W terminal, I've got a Y terminal, and it's got the blue with a pink striped wire on it. That is Y coming from your field connections, your wire nuts. That connection that you make with the thermostat wire goes through the high pressure switch. So we can check that high pressure switch right here, okay? Don't go in the back of the terminals. I hate that. You should be able to find it a better way to do it besides messing up all the plugs. So we're going to check this Y to the common terminal, and you can see here that I've got 25 volts. So in addition to making a call for cooling or heating, there is the high pressure check that is included in that voltage. Okay, so if it makes it to the board knows that the high pressure check or the high pressure switch has already been checked. One other check you can do is going to be down here on the bottom right side. All right, it's going to be your CNT terminal. That's your contactor terminal. Okay, it is going to be this kind of purplish looking wire right here. If I were to pull it off, you'll notice that the unit's going to cut off because I killed the 24 volts to the contactor coil. But if you had a unit that wasn't running, you could put your lead on common and check that CNT terminal right there, and you can see in our case I've got 26 volts. So if the board is sending power out, then it's expecting something to run or expecting a signal back from something like a switch. But in our case for the contactor, it's sending 24 volts out on that CNT, and it's going to power the contactor coil. All right. So if you have 0 volts, then that board is not trying to turn on the contactor there. So back in play it is. A couple quick checks. It's really, once you learn your meter and you learn what terminals are on the wiring diagram, you can look at that diagram and see. And once you realize what terminals do what and how the pressure switches are connected, you can easily do a couple simple voltage checks and figure out where your problem is on this board. So hope that helps. Y'all have a great weekend. I'm out of here.